This is where we are creating world's strongest recycled material out of waste carbon fiber. So we're the first commercial fiber alignment machine on the market. So the process we've developed is essentially high-tech paper making. In paper, you create a randomly orientated material where we actually align all those fibers. So in that sense, it's the opposite of paper. So we've got a hydrodynamic alignment process. So it's been 5 years of sort of getting to this stage from idea, lab scale, to actual machine that we can start doing extended shifts on to really solve the challenge of carbon fiber recycling.
Today we are at day 2 of our Tour de UK. I wanted to record something here for quite a while. It's Lineat Composites, and we'll be welcomed by Lawrence, one of their co-founders. Let's move in.
Hi, Yannick, how are you?
Hey, Lawrence.
Welcome
How are you?
Yeah, good. Welcome to Lineat HQ. Let's
Thank you.
show you around.
Sure.
So, welcome to Lineat HQ. This is where we are creating world's strongest recycled material out of waste carbon fiber.
Good.
So essentially what we do at Lineat is we buy chopped carbon fiber waste recovered from industrial waste or end of life. And we build machines to realign these fibers into a highly aligned fiber tape. So we're based here in Chepstow in Wales. This is where the goods in is. So we've got various types of fibers. You see the big boxes on the top, T300, T700, some M40J, IM7, lots of types. We've probably seen over 30 different types of recovered carbon fibers. We've got our preferred ones. So 90% of what we do is with industrial waste fibers. So we know the fiber type, we can control where they come from, but we occasionally do look at those custom end-of-life fibers as well. So I'll run you through that process now.
Good. Let's go.
So we measure out 1 kilo batches and we fill up the slurry tanks. Those are the 2 tanks you can see in the back there, which is a high concentration mixture. And it makes it a lot easier to dose the amount of material. We then pump that into what we call the wet tower. So that's where we do sort of our dispersion magic, because these fibers are normally quite clumpy and fluffy. And in there, what we do is we actually separate them into individual filaments. It then goes to the first conveying system. That's where we do the alignments. So we've got a hydrodynamic alignment process where we spray this mixture of fibers and water between parallel plates. So that's the patented process. We circulate around 200 liters per minute of water on here. We pump that to the process zone. We then have a vacuum system. So we extract all that water again, but the fibers have landed onto a mesh belt in their aligned state, and we reuse that water. So even though we've got quite a lot of water moving, we don't use 200 liters per minute because we just circulate and do a filter the water. So it's a closed loop process.
And the remaining fibers, they have a certain level of humidity.
Exactly. Well, they're very wet. So more than 100% saturation by fiber weight is water. So we move that, and then we've got a second system here, tunnel dryer, where we evaporate that water, similar as paper making. So by paper, once you have a forming wire where the material is made, you then dry that before you wind it. So we're the first commercial fiber alignment machine on the market. And we've learned a lot from that and operating it.
Sure.
But to really solve the challenge of carbon fiber recycling, it needs a lot of these machines and bigger machines. So we've worked with suppliers in the UK to really be ready that if the demand is there, instead of building 1 more machine, directly build 3 new machines. And that's the unit next door that we're ready to do that expansion. So it's been 5 years of sort of getting to this stage from idea, lab scale, to actual machine that we can start doing extended shifts on. And it's been, I think from my point of view, it's really interesting there's this idea of aligning fibers, and it makes sense because then you get that strength back. But to really convince someone or show someone, you've got to build the machine first, start testing that machine, fine-tuning and adapting it, producing the material to then offer that material, all of those steps before you get somebody, we want to buy a machine. So that's really where we are, is getting ready to expand on number of machines because we have the suppliers for it. but we'll always have some production at Lineat, because that's how you improve the process, by doing it yourself.
Yeah. So it's going back to continuity with short fiber material.
Exactly.
Kind of, trying to go back to almost virgin with some, of course, some pros and cons. But maybe you can tell us also on the final product, and we will see it soon.
We can have a look.
I mean, you mentioned it's a bit fluffy. So from the surface compared to a virgin fiber, it's certainly, as you said, fluffy, hairy. So there, I can assume, benefits in entanglement between the fibers.
So when we buy the fibers, they're quite fluffy. Once we have aligned them, it's actually in a very aligned state. So it's a little bit, let's say, loftier than virgin carbon fiber, but it's more like a normal continuous fiber UD than you would see with a felt material. And going a little bit back to the origins of the process, the origin was to make a more formable fiber material. So this was in the 80s, developed in the MOD. Making composite parts is very difficult. Shaping continuous fiber yarns into a 3D shape is very difficult without bridging and wrinkling. So the idea was, can we somehow create an aligned fiber material that can stretch and shape around forms? So that's one of the, now sort of 30 years later, one of the key benefits we're seeing is that people who are using this material have really good outforming.
Okay.
So in a lot of manufacturing facilities, your outer surface, your quality is very important. With continuous fibers, you get pitting. And if you use one of our materials, it actually forms better to your mold tool because it can stretch. So quite often people ask me, how does it compare to virgin carbon fiber? Is it 80%? Is it 90%? Well, depends how you test it.
Yeah.
Compression, shear, tension, flexural. Pure tension, you're not going to beat a continuous fiber material.
Yes.
So that's where we sit around 60 to 70%. But if you're looking at shear properties, we actually get an uplift in performance. And this is the exciting bit, I think, now. It's like sustainability opens the door. But once you test and you see those benefits in part manufacturing time reduction and improved shear properties, that's often where there's a real benefit, not just from sustainability, but also cost. So what we do, we produce about 100 square meters of material here. We sample at the start, at the end of the roll. So we measure the grammatur in German, I think, the aerial weights. And we log that for every tape. And then we also take a sample of about 1.5 meters that we then make into flexural coupons and test here. Okay. So we track that throughout for consistency. You can see this camera. So we're implementing that at the moment to spot defects and width variation. And we're working on inline alignment analysis tools that, even though you see a tape and you're probably like, yeah, that looks aligned. How aligned is it? And what performance can you expect? And we're building the predictive tools for that as well. Okay, so this is where the magic happens. Before we focus on there, I'll briefly show you the mixing process, just so you see it through. So this is that loop that I mentioned of about 200 liters per minute. And we just drip feed the fibers in. Obviously, we're adding a slurry, so we're adding more water.
Yeah.
So every now and then we have to remove water, but that goes in the second tank that you saw to make the next mixture. So it's a closed loop process.
Thanks. So now we are coming out.
And now the best bit. I think this is where you go, The mixture is coming in here. And if you now go through your knees, you can see all these little jets.
Yeah.
And we physically confine the fibers. So we got a controlled alignment because those gaps are fixed. The fibers land on the moving mesh conveyor belt. The water goes through, so that's this pipe here. We reuse that, and the fibers end up aligned. We add a low percentage binder on here. When you don't add a binder, the material falls apart. So we add a low percentage binder. This is our old oven. We don't use that anymore. And then tunnel dryer. We're working with suppliers who provide us with a tunnel dryer. That's where we remove the residual moisture. We set the binder, and then you can wind it. And then I can show you the shelf here. This is what we produced, and this is waiting to be shipped out or get pre-pregged. So this is our stock. So from the production settings, we log which batch was used, what were the settings, what was the aerial weight before and after, and then sample taken, waiting for testing in our composites lab, and then that sits here ready to go.
And Lawrence, just as a reference, how long does it take to make one spool?
One of those is, we make about 2 of those a day, and then an extended shift about 3. So yeah, that's 500 linear meters, 100 mil wide, 50 square meters. That's our pre-pregging machine that I just said, but actually it's laminating, so sort of semi-pregging. But we can, and we have in our freezers some resin film, we can combine that and supply pre-impregnated material.
Yeah.
And then behind that is our tape slitting
So
capability.
you can do semi-pregging, and if you need to do real pre-pregging, you can find partners.
We're looking to do that with partners because,
Very cool.
well, let's same on the wheel analogy. Let's not reinvent the wheel. And then this is where we're playing around with slitting a bit. So if you say the width, this is where you can see the aligned tape.
Okay.
And if you pull on it, you'll just break it. You can break
So
that.
that's a 4 millimeter.
Yeah. And you don't break fibers there. You break the bond. That's essentially the sizing or the binder. And then this is what you get if you slit the edges of the tape. So you just saw it being wound.
Yeah.
This is like a really nice clean edge. And that means that on the machine you can put these together, wind them side by side, and make it into this wider sheet material, make it into a non-crimp fabric, or weave it. So that's some of the samples that we can show you upstairs.
Cool. Very interesting, Lawrence. Well done.
No, thank you. So it only took 5 years.
Nice.
I think we...
Let's see what happens in the next 5 years.
Exactly. That's the spirit.